SAFE Software is pleased to present the 2009 FME International User Conference. This session is presented by Steve Milroy, a senior architect with OnTerra Systems LLC, who focuses on mapping and geospatial applications. Steve is recognized as a regional director and MVP by Microsoft and has presented at developer conferences, user groups, and business associations on solution and development topics. This session is presented by Eric Jan-Bodwitz, a senior software engineer at Vickery.
Well, good afternoon, everyone. Thanks for attending my session. I know it's kind of late, getting late in the day on the last day, so people are maybe hitting the spa and trying to take some time in Whistler. But we certainly wanted to share with you kind of Microsoft's vision around some of the geospatial things that they're doing. So what I want to cover today is really using FME with Microsoft Virtual Earth, which, if you haven't heard by now, I guess you've been asleep. It's changed to Bing Maps, and I'll talk a little bit about why that happened, why the name change happened. The reality is, from a functional point of view, nothing's changed. It's just a branding change, and so we'll talk a little bit more about that. And then we'll also talk about SQL Server and how FME really facilitates the integration of existing data sets and other spatial data with SQL Server 2008. As Miles mentioned, I'm a solution architect. I mostly work on web-based mapping and also some other line of business applications like fleet tracking and route optimization. And I've used FME, I'd say more at the novice level to pull data from different places, mash it up, integrate with SQL Server. And it certainly is a good tool. So I'm kind of excited to share what I believe is the ways in which FME can be used to integrate, these products, these technologies with a lot of the things that you've been doing. So to kind of recap, again, not a lot of Microsoft people position what they're doing because, as you probably recognize, Microsoft has many different teams, and they often build great technologies that are somewhat in a silo, and then obviously it takes partners and sometimes customers to bring them together into solutions. And so what I do is I represent what Microsoft does at a little bit more of a platform level, because I think there's real value in the capabilities of certain pieces of the platform. A lot of people say to me, is Microsoft trying to become a GIS vendor? And the answer is no. They're a tools and technology vendor, and they're just supplying distinct pieces of functionality that you can integrate, and we integrate into customer solutions. So whether that's just address validation and geocoding, or whether it's doing spatial queries in the database, those things can be integrated piece by piece, and you don't necessarily have to integrate everything or buy the whole product and the whole platform. You really use what's most useful to you. So from a visualization point of view, and by visualization, I kind of mean data visualization, spatial visualization, that's probably been one of Microsoft's biggest areas of focus over the last sort of 10 years that they've been doing web-based mapping. And that really manifests itself in Virtual Earth or Bing Maps for Enterprise, which I'll use those terms interchangeably today, but officially the name now for Virtual Earth is Bing Maps for Enterprise. So VE is really the platform of services and capabilities that Microsoft provides that allow you to do visualization. And in addition to that, they also provide the 3D capabilities as well. So if you want to visualize data in 2D, you can do that very easily. And unlike some of the other web-based mapping vendors, the 3D plugin for Virtual Earth actually is part of the same API set. In fact, the tiling and everything else in 3D is actually the same in 2D. So if you have tile overlays that work in 2D and then you want to see them draped over the DEMS and in relation to building models, it's exactly the same. You don't have to create different tile sets, different layers to get it to work. And then I mentioned photosynth here. It's really not that relevant to FME today. It's really a technology in which you can take a whole series of photos, and they don't have to have any other context except be in the same area, and you take them and you synth them effectively, and what it does is it's an image matching technology that just overlays the images and creates a synth and effectively a 3D model from the photo overlap, and then you can allow people to navigate those photos. It's not really a geospatial technology as much as a spatial technology, in that it just takes any set of photos, synths them together, and then you can allow people to explore that synth view. So it's good for things like real estate and exploring an object. There's plenty of synths up there. From a 3D perspective, a lot of people don't know, but you can do some pretty powerful things with VE3D. It's a .NET control that runs in the browser by default, but you can also, there's a set of APIs that aren't well publicized that allow you to natively call the .NET functions, add plugins, integrate, even manage DirectX code, so you can really create almost simulators using 3D or playback data in 3D using those APIs. And then spatial data, that really has two pieces. The first piece is obviously the common data sets that Virtual Earth has, and I kind of call them the commodity data sets, base road information, public orthos, geocoding, routing. They're the things that many customers don't really have the server capacity or the resources to keep that data up to date. And that's really where Virtual Earth has a lot of value, is you can let Microsoft take care of those base layers, and then you just layer on top your value-added layers. From a customer data perspective, that's really where SQL Server 08 comes in. If you have any type of spatial data, you can load it into SQL 08, you can index that data, and then obviously query it using any of the 70 plus spatial queries that exist or spatial functions that exist to manipulate that data. So think of this as kind of public or commodity data sets. Think of this as just an engine that stores your data. And so you can obviously bring these together, use Bing Maps for Enterprise as the base map layers, and then use SQL Server to store and allow you to query and overlay data on top of those bases. So FME really provides a lot of cool features to bring these pieces together and bring your existing data together. From a desktop perspective, I use it to take shape files and other content from GIS users and get it into formats that Bing Maps for Enterprise supports, whether that's KML, which is directly supported, GeoRSS, or even JSON files that then you can use the the add shape functions to just manually draw each point, line, and polygon on top of the map. And so they're certainly good things. What you probably saw in the session from Dimitri yesterday, if you didn't, is you can also pull in raster data very easily into Bing Maps for Enterprise, and that's in the form of these custom tile layers, raster tile layers. The format, the schema of those tile layers is industry sort of known. It's not a Microsoft specific thing, so it's the same as what Google Maps is effectively doing, but it allows you to take any data, whether it's real-time weather feeds, if you wanted to pull in a raster, tile it on the fly. Obviously, FME Server is a good product to do that real-time tiling on the fly. If you want to take shapes, or I see it often for people that are wanting to overlay parcel information or zones that doesn't change that often, then you could do a weekly process that tiles that out, and then any user just sees those cache tiles on top of the map. So there's lots of value in using these products, and we'll talk more about those. And at the end of the day, it's about extending your existing investments, taking the things that you do, whether it's in Esri or MapInfo or AutoCAD, and really just extending them out to other types of users. And it allows you to reuse skill sets and technologies that you're probably got people in your organizations that are familiar with .NET and SQL, and these are all the pretty common technologies. So let's just spend a little bit of time. We don't have a lot of time. I could literally spend an hour talking about the architecture and the different services. There's a couple of key things. Bing Maps for Enterprise is hosted by Microsoft in multiple data centers. Up until recently, it was 2 data centers, but now Microsoft's implemented a customer data network, which is basically edge caching technology. So 15 different data centers worldwide have the raster content, the base map information, as well as the imagery, the orthos, and the obliques. And so if your user is in Europe, they're going to pull those rasters from local data centers. And in North America, the performance on the West Coast is actually 85% faster than it was prior to having that edge caching network. So there's a lot of advantages. So the data sets here, again, are just common data sets. The map data in North America is Navtech, road information. Worldwide, there's other providers. Microsoft acquires it and puts all these pieces together. And this is updated every 90 days or so, depending on the vendor release cycle. The imagery includes obliques from pictometry primarily, and then orthos from Digital Globe and other vendors, including the UltraCam, which is a camera system that Microsoft owns. If you heard, they acquired a company called Vexcel based in Boulder, and that UltraCam is actually acquiring data that's feeding in. And it's actually the high overlap ortho imagery that's being used to create the building models that are seen in VE3D. They're automatically created, unlike other 3D tools that you manually create all the models. They're automatically created with the photogrammetry process that Vexcel developed. So there's some of the key things with geocoding. You can do parcel-based geocoding. So for 85 million US addresses, you get the centroid of the parcel. It's not interpolated. So these are all different features that you can take advantage of, and you may choose all I want is traffic, or all I want is geocoding. You can really pick and choose the pieces that you want. From an applications perspective, the consumer side of this, and that's been sort of the big head-to-head battle with Google and Microsoft, is on trying to capture the consumer attention when it comes to local search and web-based mapping. And that's really the underlying reason for the change in name. Is Microsoft did a terrible job over the last couple of years of branding it. You've probably heard MapPoint and Virtual Earth and Live Search and Live Maps and MSN. There was just a lot of confusion, and so they wanted to make the change once and for all and switch over to this common brand. So it's really about consumers, but the reality is the Virtual Earth name itself is also being changed to Bing Maps for Enterprise. From an enterprise perspective, you're going to build applications that leverage some of the APIs that are making these services available. So there's a JavaScript and Ajax API that is similar to the other vendors out there that have web mapping that allow you to basically do the interactive web-based mapping. Microsoft also has a SOAP XML API, so if you wanted to do batch geocoding and geocode things, you wanted to do routing, but you didn't necessarily need to see the map in a web browser, or you just didn't have a web-based application. You're using a mobile app or a desktop application. You can get all the content through the SOAP XML APIs. And then there's also a couple of other APIs, and you may have heard of the Silverlight API. It's like any of the sort of plug-in based browser technologies. You install the Silverlight plugin, and it gives you a lot higher performance. You develop your applications in .NET, they run in the browser, and then you get high vector data performance and other things that you just can't get with Ajax and JavaScript. So hopefully that's a good summary of kind of what Virtual Earth or what Bing Maps for Enterprise provides, and we'll just jump in and look at a couple of demos in a second. So from an FME perspective, you can, again, sort of manually transform data into Virtual Earth format, and that could be in the form of, again, GeoRSS, KML, custom tile layers. You can really pick and choose the format that makes the most sense. The thing I typically warn people with using KML and GeoRSS is in a browser with JavaScript, you do have limitations in the performance, and I'll show you an example where I think this customer is actually at that upper limit where it would make sense for them to use FME and just tile that data out and then just look at it as a raster overlay on top of the map. So you can do it again manually, where you maybe schedule it once a week, or FME Server has the ability to stream that data. So I often give the example of weather, where you may be getting updated weather feeds every 5 minutes, and you want to take those weather TIFFs and tile them out and deliver them to users of your application. Or traffic's another good one, where you want to tile that traffic flow information on a regular basis. You could use FME Server to do that. And it's really about supplying data to these web-based mapping applications is really the key scenario for FME and Bing Maps for Enterprise today. SAFE has created a couple of writers that are useful. There's the Virtual Earth Tiler, and this basically just takes raster data and it tiles it for you. So it basically matches the Virtual Earth tiling scheme, which I'll talk a little bit about in a second, and it just writes the tiles out to a directory. The Virtual Earth HTML creator, which kind of is an adjunct to the Virtual Earth tiler, is basically just a mashup builder where it'll spit out all the HTML and all the code and all the tiles so that it all lives in a directory, and you can literally have a site up and running. And I often use that just to generate the stub code, and then I take it into other applications that have the customer's user interface and so forth. What I also see pretty often is customers that want to take vector information and tile it out. And there isn't an automated way to do that with FME today. I've been working with the guys, and that's what really Dimitri talked about yesterday. Tiling data or rasterizing data is a pretty intensive process. So trying to do large data sets and rasterize and tile that is a pretty intensive thing to do. So you want to obviously be selective and make sure that you're only tiling things on the fly or only tiling it once a week, because it can take hours to tile many different zoom levels with all the data that you may be supplying. So this is the tile system that Bing Maps for Enterprise uses. Again, they're raster tiles. They're 256 by 256 pixels. It's a quad tree based system, so it's 19 zoom levels where each the quad key represents the zoom level and the position of that tile within the overall tree. So at a world level, it's 4 tiles, and it's 0 through 3, and it exponentially goes up from there. And so you can see when I get down to street level, which is zoom level 19, I've got millions and millions of tiles. It's a massive amount. It's Mercator projection, and it uses WGS84 coordinates. And the key thing is that for some applications, like if you were oil and gas working on the North Slope or something, Virtual Earth's probably not going to work very well. And actually, if that was a scenario that you really want, most oil and gases have Esri-based products. You can actually get Virtual Earth content in ArcGIS Server 9.3.1, and so you can use different projections and different coordinate systems through their APIs. But through Virtual Earth, through Bing Maps for Enterprise, you are really limited to this standard tiling system. So let's have a quick look at how this all works. We don't have a huge amount of time. So one thing I wanted to just quickly show you is I have a, this is the application. Let me just refresh that. This is an application that was created by the LA Department of Housing, and they use it just to allow people to visualize the areas that they're providing sort of services, or they're trying to improve the quality of the neighborhoods and things in LA. And so they have this information all in Esri today, and they export it out and they make it available to people. So you can log into this site, you can enter your address, and it says whether you're in a stabilization zone and which zone you're in, and you can visualize it on top of the map. And this is all done in vector, and this is a site that I would consider to be borderline needing to be rastered. It's still refreshed pretty quickly. It's easily over 1,000 individual vectors, but at this point you probably want to go to raster. And so one thing that I've been telling them is, why don't you use FME to rasterize and tile the data that you have. And so that's what you can do with FME. And I have a workflow which Dimitri actually created initially, which I think kind of led to his talk yesterday, that I'd be happy to share with you after if you want to play around with it. Just pop that open. I'm not going to go through it all now, but it basically takes it, the raw data, and I have shape data here. This is coming from the LA Department of Housing. These are the different zones that they're doing, this neighborhood stabilization programs on. And so this is a typical format that I see with customers, and they want to get it into Virtual Earth. Again, you could take that and you could convert it to, into GeoRSS or KML, and that's what they're currently doing, or you could tile it out and show it as tiles. So this workflow, this workspace basically goes through that whole process, and it ends up with the raster tiles. So I'm not going to spend too much time on that. Again, if you want the sample, I'd be happy to provide it to you. But basically, basically that sample tiles out all of the tiles, and that's what you can see right here. So it's these individual little tiles, And then with VE, it's a very simple process. Just trying to load that sample. Okay, why isn't it loading? It's a very simple process. It's just taking a little while to load on my machine. I'm running a web server and SQL server and everything else off my local machine here, but it will load the base map and then it'll show the individual tiles. I'll keep plugging along. There it goes. And so you can see these tiles are now overlaid, and as I zoom in, it'll fetch the tiles at each zoom level. Okay, so let's keep pushing along because we've only got 5 minutes left. And I want to spend time on SQL Spatial. So in 2008, in SQL Server 2008, and this is every version from SQL Server Express up to SQL Server Enterprise Edition, in 2008, Microsoft released the Spatial extensions, which include 2 new data types, spatial data types, flat Earth, which is the geometry data type, and then a round Earth data type, which is the geography data type. So you can now store your spatial data natively in SQL Server using these data types. And they're actually .NET data types, and that's one thing that people don't initially realize is if you have an application that has a client-server architecture or you want to run some of this spatial manipulation with the functions in the client and store data in the server, you can actually access those spatial functions outside of the database because it's just a library of functions that Microsoft provides. So you can apply spatial indexes to the data, and then there's 76 different functions that you can call that are all OGC compliant, and it includes things like buffers and area calculations, distance calculations. Ed Katabar down the front here is actually the SQL Spatial guy. So if you want to ask him about specific SQL Spatial things today or in the future, or you want to tell him about some of your scenarios, he's the main guy. So, and then from a development perspective, you can integrate with .NET, ADO.NET. It's really using your common sort of development skills. So you could write your spatial queries in Transact SQL, or you could use .NET and actually just write your queries in .NET, which a lot of developers like as well. That little window down there, by the way, is just the built-in spatial viewer that if you have spatial data, you can view it very quickly. So from an FME perspective, you can read and write spatial data to and from SQL Server 08. There's an edition of FME Microsoft SQL Server Edition, which gives you this capability. It gives you SSIS integration, so if you want to actually run the workspaces within SQL Server, you can do that as well, so you don't have to run them externally. And there's so many different scenarios that you can use it for. Primarily, it's for loading data and retrieving data, but certainly cleaning up data, joining polygons, building polygons from lines that may be in the data. You can do that and then write it out to other tables that are within the database. So let's just have a quick look in the last 2 minutes before I get the hook. Let's just write a quick little it's a quick little workspace that takes data from the shapefile. So and we'll define where that is. And obviously, being a government data source, that's actually California state plane data, which, working with web-based mapping, it's not such a good format to be working with. And then the destination is going to be our SQL server. So we'll do SQL Spatial. And basically I can connect directly to the SQL server. So I'm going to do localhost. Database is Spatial DB. Then I can choose one of those two data types. I'm going to choose geography. Geography is what you use primarily if you're doing web-based mapping. You're going to use geometry if you're doing other coordinate systems. Let me just finish this demo and then we'll do Q&A. This is this thing that you say. This is actually the column names. So
no, it's the table.
The table names, sorry. Yeah, the column names are the... The only other thing I need to really change here is if I want it to be in geography and use lat long, then I need to obviously do the reprojection. So let's just...
Before you run it, you need to go over to your destination, right-click on it, and populate all the attributes.
Yeah. I'm just showing the spatial data that's coming across. But yeah, I'd populate all the attributes and then all of that data would come. But just for time's sake, if I just wanted to see the spatial data that's coming across, so any questions while we're waiting for that as we're wrapping up? So there's our table that we just pulled in that shapefile. I can query that. And I'm using SQL Server Management Studio, so this is how you can manipulate the data without having to write queries all the time. So there's our spatial data, which is the binary data. I can look at that shapefile that's now reprojected. And I can also then start applying some of those spatial functions like st as text. And you'll see the text version, the well-known text. So that's pretty much it. Any questions? I'll just pop up a summary, and it's really about leveraging what you already have, using Big Maps for Enterprise as a data visualization engine as well as a set of services, and using SQL Spatial as a way to store that data in SQL Server and query it and manipulate it. And one thing that most people don't know is with Big Maps for Enterprise, you can actually turn off the base layers altogether. And I see this a lot in a lot of government scenarios where if you have better data in those areas or you want to use other data sets, you can completely turn off the base data and it effectively gives you your own sort of map interface. So any questions? Well, thank you very much.
Thank you, Steve.
Thank you.